All right, so in this video, we're going to talk about the operation of matrix multiplication. And just to clarify, this is different than scalar multiplication. So scalar multiplication is when we have a scalar value on the outside of a matrix. Remember, when we multiply all the different parts of a matrix, matrix multiplication would be taking two matrices and multiplying them by one another. So a few rules about matrix multiplication that you need to know. These are very, very important. 1, matrix multiplication is not a multiplication of corresponding parts. So it's not like addition where you add, if you add, or subtract where you add like the first two parts together. You cannot do that for multiplication. It works a different way. We'll talk about that. Secondly, matrix dimensions do not have to be the same size. So that's important, unlike addition or subtraction where they have to be the exact same size. That's not true for multiplication. However, multiplication can only be done if inside's dimensions match. So let me give you some examples of that. If I multiply a 2 by 3 matrix times a 3 by 5 matrix, this is valid because the inside dimensions match. And the result for such a multiplication would be a 2 by 5. Notice those are the dimensions that I have remaining. All right, if I give you another example, I could do a 3 by 4 times a 4 by 1. This is valid because these inside dimensions match, and the result would be a 3 by 1. I could not, however, do a 2 by 3 times a 2 by 3. These inside dimensions do not match each other, so this multiplication is not defined. All right, so let's look at how multiplication actually works. So we're going to try to multiply both of these ways. You can call this example 1 and example 2. So first we're going to find A, B if possible. So I'm going to name A and B. I notice that A is a 2 by 3. Remember, we do rows times columns. And B is going to be a 3 by 2. So it is always important that we start here. These inside dimensions do match, which means I'm going to have a result of a 2 by 2. And now I'm going to draw out, and I am drawing this large, so I would do that for yourself too, because you need some space, a 2 by 2 with some blanks. Okay, so we notice, remember we do rows by columns, and we are going to find this spot right here is the first row, first column. And so that means I am going to look at row 1 and column 1 in that order. And when we multiply, we're going to multiply the corresponding parts and then add them together. All right, so I'm going to get something like this. Notice I did the first times the first, second times the second, third times the third. And then I will add those results together. So in this case, that would be 12 minus 9 minus 4, so negative 1. All right, now for this next spot, the second spot that I'm going to be working on, this spot is in the first row, second column. So this time I'm going to use the first row and the second column and complete the same step again. All right, so as you're copying these down, I would encourage you to copy down these labels that I have down here, as well as each of these multiplication parts. And then again, you multiply and add them together, so the final result in this spot will be 12. All right, now we're going to move on to the bottom row. This next spot is in the second row and the first column. So I'm going to multiply second row, first column. And I would encourage you at this point to pause the video to see if you can get the same result that I do in this spot. All right, so this is the set of multiplication I got, which when I add all that together, I think is going to give me negative 21. All right, and now I would encourage you again to pause the video, see if you can label this last box down here, and then set up the multiplication for it as well. So in this spot, we are doing row 2, column 2, so row 2, column 2. And when I perform, this is the set of multiplications that I got there. You can see right here. And when I work that out and simplify, I'm going to get 42 as my value. Okay, so now we're going to do b times a, which means we need to switch the order. So I'm going to move a to this side. So in your notes, I would encourage you to recopy these questions in this order, b times a. And the first thing we're going to do is check our dimensions to see if this is even a possible operation. So if I do b times a, b is a 3 by 2, and a is a 2 by 3. Notice this time the inside dimensions still match, but my result is going to be those outside parts, so my result is going to be a 3 by 3. So just as I started the last example, I'm going to start by drawing myself a large 3 by 3. If you didn't skip lines last time, hopefully you see you probably should do that now. And we're going to do that here and go ahead and set that up with the blanks. You don't have to use the blanks, but I think it really, really helps to keep yourself organized. All right, so I'm going to walk you through this first row one more time, and then I'll have you pause the video, see if you can finish it. So these different spaces, maybe start by naming where they are so you can see which columns and rows you should be choosing. All right, so in this first spot, we're going to have row 1 and column 1. Notice this time I have less things to multiply and add together. So in this case, I'm going to have 6 times 2 plus -2 times -1. Now I'm going to move on and do first row times second column, and then I will do the first row times the third column. This will give me 6 times 3 plus -2 times 5, and 6 times -4 plus -2 times 0. And as we've seen, this process is going to repeat again using the next row. So now we're going to use the second row and first, second, and third column. That will be these next 3 spaces. And then we'll proceed to use the third row, first, second, and third columns, which will be this last row down here. And so at this point, I again would encourage you to pause the video and try to fill out these last 2 rows to see if you can get the multiplication part set up correctly, and then I will give you the final answer to check to see if you were correct. All right, there's my multiplications for the second row. And when I simplify, this will give me a final result of 14, 8, -24, -14, 39, 12, 0, 13, and -4. All right, so comparing these 2 examples, I want you to also see that when we multiplied these in a different order, we got a different answer. So these 2 final products are obviously not equivalent to one another. So it does matter the order that you multiply. So you need to know that the order does matter and it can give different results. All right, so the last thing I want to show you is what happens when we multiply by the identity matrix. So the identity matrix should look familiar to you. It's very similar to reduced row echelon form. You should see these ones appear diagonally. This can happen in a 2 by 2, 3 by 3, 4 by 4. It does happen in square matrices only. And something special is going to happen when we multiply by the identity matrix. So I'm going to go ahead and set that up for us. And in this instance, this is a 3 by 3. Times a 3 by 3. So the insides match, which is good, which is going to result in a 3 by 3. So I'm going to go ahead and set that up as well. And I'm not going to go all the way through this process, but I am going to do a few of these. So first row, first column. Notice that I like to work a row at a time. I think it just makes it easier to keep track of what I'm doing. So we're going to do first row, first column, first row, second column, first row, third column. When I do this and I match the multiplication up, notice that in the first row I get -2 times 1, and then I'm going to have 7 times 0 and 5 times 0, which are both going to equal 0. So this first spot is just going to equal -2. In this first row, second column, so this that's in blue, the first value is going to be -2 times 0, which is 0, 7 times 1, and 5 times 0, which is going to just give me 7. And then in the last row, again, I'm going to be multiplying, the last column, I'm going to be multiplying by zeros in these first 2 numbers. So I'm just going to be left with the product of 5 times 1, which is 5. So notice a few things are happening. I'm multiplying by 1 each time. The zeros aren't going to add anything. And you should begin to recognize fairly quickly that this first row is still this first row. So when we multiply by the identity matrix, we're going to get the exact matrix back in return. So I don't even have to work this out, though I could to prove it to myself. I'm going to get 6, 3, and -4, 9, -1, and -8. So a matrix times the identity matrix is the matrix itself. So this still equals the original matrix itself, and that is important to note.